My name is Andre Isaacs, and I'm an associate professor of chemistry at the College of the Holy Cross in Worcester, Mass., and I am one of the members of ccas. ccas is a center for chemical innovation that is funded by the NSF. And the goal of NSF is to fund these centers to really address big challenges in the chemical community through research innovation and, of course, broader impacts on the general population. And for ccas specifically, as a CCI, the vision of ccas is really to transform how we develop, how we interrogate, how we optimize and apply new reactions to the synthesis of functional molecules. And how we do that really is through using data science tools, computational workflows, and that will help to address some of the challenges we face. So there are a number of challenges I think we face in the scientific community, particularly as an organic chemist. I think we can benefit from using data chemistry to help us do a lot of the work we do, right? So machine learning is critical, I think, to the future of organic chemistry. In ccas, there are a number of ways we can address that. One is we can use these data tools for reaction optimization, right? And so reaction optimization, where you can develop algorithms to find optimal conditions for your reactions by surveying parameters and predicting using machine learning what combinations are going to work out best for you. You can also use this to develop new reactions, right? And to kind of probe new chemical space. And also to think about how simple transformations, right, can map onto more complex environments and be able to predict that. So I think there's a huge role that this work has to play in the future. So I work at a liberal arts college with exclusively undergraduates. And our research goals are really to we do synthetic methodology, right? So we're developing new reactions, specifically ones focused on click chemistry. So we're using click chemistry, and we're taking the products of click chemistry, decomposing that product, and then trapping them to make other nitrogen heterocycles. For us, that's a very, very exciting area of research because heterocycles are found in a lot of the pharmaceutical drugs out there. And so coming up with new methods for making them is really, really, really important. Now that fits in really, really well with ccas because ccas has a lot of work around developing reaction optimization programs. And so currently, our research group is using a program called EDBO Plus that's developed out of the Doyle lab at UCLA. And we've used that to great effect, and it's had significant impact on our research so far, where we've been able to optimize our reaction conditions, and we are seeing improved yields on our transformations that without the aid of this algorithm, we would not have been able to do. Because as you think about reaction optimization, you're thinking about pairing, catalysts with bases, with solvents, and if you're not surveying the entire landscape, right, then you might be missing interactions between one parameter and the other that might be optimal. And so it's really helped us streamline that. And for undergraduates, this is great, right? Because instead of running 1,000 reactions, you might only have to run 50. So this, for me, is an example of how ccas and data chemistry can really, really improve the work that we do. Yeah, I would say to younger people that, this is an exciting time to enter, I would say, data chemistry. It's a growing field. I mean, we don't have to look, very far. We look around us to see what machine learning and artificial intelligence, the role it plays in our lives. And so I think for a lot of young people nowadays who are craving, like contributions to not just chemistry, but computer science and statistics, data chemistry kind of houses it all, right? So this is where you can really be doing science and making contributions across all other fields to really have a big impact on science and technology. So I would say to them, jump into it, right? This is exciting work. You get to work with chemists, you get to work with people who do computational stuff, and you can do either side, you can do both. And you're making a big difference. And ccas is important for young people I want to point out to them that, one of the things we do here, and I think we do well, is that the center is really focused on educating and training the next generation of data chemists. And so one of our primary goals, I would say, is to mentor graduate students and postdocs and undergraduates in this work. And that's been part of it that I've really, really enjoyed a lot. Also, the community of people in CCAS, particularly for me, also the DCN, which is the Data Chemist Network, which I'm excited to be a part of. And to explain what that is, that's really a group of faculty members who are from historically excluded groups and institutions that aren't typically part of these large NSF-funded centers. To be a part of this as a faculty member at a liberal arts college is really exciting, to bring our talents to bear on this work.